Welcome to this comprehensive guide on the order of operations. Today, we're going to explore one of the most fundamental concepts in mathematics that ensures everyone gets the same correct answer when solving mathematical expressions. Imagine if we didn't have standard rules for solving mathematical expressions. Consider this simple problem, 6 plus 2 times 3. Without agreed-upon rules, some people might add first and get 24, while others might multiply first and get 12. Which answer is correct? This confusion is exactly why mathematicians developed the order of operations, a set of rules that tells us which calculations to perform first. These rules ensure that everyone arrives at the same correct answer every time. The order of operations is remembered by the acronym PEMDAS. Each letter represents a different type of mathematical operation, and they must be performed in this specific order. Many students remember PEMDAS using the mnemonic, "Please excuse my dear Aunt Sally." This friendly phrase helps you recall the correct order when solving mathematical expressions. The fundamental principle behind PEMDAS is consistency. No matter who solves a mathematical expression, if they follow the order of operations correctly, they will always get the same answer. This creates a universal mathematical language that works the same way everywhere. Throughout this video series, you'll master each component of PEMDAS through clear explanations and guided practice. We'll explore why mathematicians chose this particular order, examine common mistakes students make, and work through problems of increasing complexity. By the end, you'll have the confidence to tackle any mathematical expression using the order of operations. Now that we understand what PEMDAS is and why it's essential, we're ready to dive deeper into each component. In the next section, we'll explore the PEMDAS acronym in detail and learn exactly what each letter represents. Now that we understand why we need a standard order of operations, let's break down exactly what PEMDAS means. PEMDAS is an acronym where each letter represents a specific mathematical operation, and the order of these letters tells us the sequence in which we should perform calculations. Let's examine each letter in detail. P stands for parentheses, which includes all grouping symbols like parentheses, brackets, and braces. These have the highest priority because they explicitly tell us which operations to perform first. E represents exponents, which includes powers, roots, and other exponential operations. Exponents have the second highest priority because they represent repeated multiplication or division operations. M and D stand for multiplication and division. These operations have equal priority, which means when you encounter both in an expression, you perform them from left to right in the order they appear. Finally, A and S represent addition and subtraction. Like multiplication and division, these operations have equal priority and are performed from left to right when they appear together in an expression. Now let's visualize this hierarchy of operations. Think of PEMDAS as a priority system, where operations higher in the hierarchy are always performed before operations lower in the hierarchy. Parentheses have the highest priority. No matter where they appear in an expression, we always solve what's inside parentheses first. Exponents come next. After handling all parentheses, we evaluate any exponential expressions. Multiplication and division share the third priority level. This is crucial to understand. They have equal importance, so we perform them from left to right as we encounter them. Addition and subtraction have the lowest priority, and like multiplication and division, they have equal importance. We perform them from left to right. The left to right rule is essential for operations with equal priority. This means that when you see multiplication followed by division or addition followed by subtraction, you don't automatically do multiplication before division or addition before subtraction. Instead, you work from left to right. Understanding PEMDAS as a hierarchy, rather than just memorizing the letters, helps you apply it correctly. Remember, parentheses first, then exponents, then multiplication and division from left to right, and finally addition and subtraction from left to right. This systematic approach ensures you'll always get the correct answer when evaluating mathematical expressions. Imagine you're working on a math problem and you get one answer, but your friend gets a completely different answer from the same expression. This is exactly what happens when we don't have a standard order of operations. Here's a simple expression. 6 plus 2 times 3. Without a standard order, someone might solve this from left to right, getting 6 plus 2 equals 8, then 8 times 3 equals 24. But with PEMDAS, we know multiplication comes before addition. So we first calculate 2 times 3 equals 6, then 6 plus 6 equals 12. Two completely different answers from the same expression. This creates confusion and ambiguity. In mathematics, we cannot have the same expression yielding different results. This is where PEMDAS becomes absolutely essential. PEMDAS is crucial in many professional fields. In science, incorrect order of operations could lead to wrong chemical formulas or physics calculations. In engineering, it could result in structural failures or safety hazards. In finance, wrong calculations could cost millions of dollars in investment decisions or loan calculations. Precision and consistency are not just academic concepts, they have real-world consequences. Consider this investment formula. If we don't follow the correct order of operations, we could calculate completely wrong investment returns, potentially losing thousands of dollars due to a simple mathematical error. This is why PEMDAS is so important. It provides consistency, ensuring everyone gets the same answer. It guarantees accuracy by giving us the mathematically correct result. It brings clarity by removing ambiguity from calculations. And it creates reliability in mathematical communication across all fields and applications. Without PEMDAS, mathematics would be chaotic and unreliable. With it, we have a universal language that works the same way for everyone, everywhere. This standardization is what makes mathematics such a powerful and trustworthy tool for solving problems in our world. While PEMDAS is the most common acronym used in the United States, mathematicians around the world use different acronyms that represent the exact same order of operations. Understanding these alternatives will help you adapt to different mathematical contexts and resources. The most common alternative to PEMDAS is BODMAS, used primarily in the United Kingdom and Australia. BODMAS stands for brackets, orders, division, multiplication, addition, and subtraction. Notice that it uses brackets instead of parentheses and orders instead of exponents. In Canada, you might encounter BEDMAS, which uses brackets and exponents. Some regions in the United States use GEMDAS, where grouping replaces parentheses. Despite the different letters, all these acronyms represent the identical mathematical order. The key insight is that these acronyms are simply different ways of labeling the same mathematical concepts. Parentheses, brackets, and grouping symbols all serve the same function. Exponents and orders both refer to powers and roots. The order of operations remains identical regardless of which acronym you use. To help remember PEMDAS, students often use mnemonic devices. The most popular is "Please excuse my dear Aunt Sally." This phrase helps you recall the first letter of each operation in the correct order. Other creative mnemonics include "Purple elephants make dreams and smiles," or "Please end my day at school." The key is finding a phrase that's memorable and meaningful to you. Some students even create their own personal mnemonics. Here's a practical demonstration. Whether you use PEMDAS, BODMAS, or any other acronym, you'll always get the same answer because they all represent the identical order of operations. The mathematical logic remains constant regardless of the acronym you choose to remember it by. Understanding these alternatives makes you a more versatile mathematician. Whether you encounter PEMDAS in an American textbook, BODMAS in a British resource, or BEDMAS in a Canadian classroom, you'll recognize that they're all describing the same fundamental mathematical principle. Choose the acronym and mnemonic that works best for you. But remember that the underlying order of operations never changes. Now we'll focus on the first two steps of PEMDAS, parentheses and exponents. These are the foundation of solving complex mathematical expressions correctly. Step 1. Parentheses always come first. When you see parentheses in an expression, you must solve everything inside them before moving to any other operations. When you have nested parentheses, work from the innermost parentheses outward. This ensures you maintain the correct order of operations throughout the entire expression. Step 2. After handling all parentheses, evaluate exponents. Exponents represent repeated multiplication and must be calculated before any other remaining operations. Now let's apply these concepts with our first example. We'll solve the expression 2 times the quantity 3 plus 4, all squared. Following PEMDAS, we start with the parentheses. Inside the parentheses, we have 3 plus 4, which equals 7. Next, we handle the exponent. 7 squared means 7 times 7, which equals 49. Finally, we multiply 2 times 49 to get our final answer of 98. Our second example involves nested parentheses. We'll solve 3 plus 2 times the quantity 5 minus the quantity 8 minus 3. With nested parentheses, we always start with the innermost ones. Here that's 8 minus 3, which equals 5. Now we solve the brackets. 5 minus 5 equals 0. Now we multiply 2 times 0, which gives us 0. Then we add 3 plus 0 to get our final answer of 3. Our final example combines multiple parentheses and exponents. We'll solve 4 squared plus 3 times the quantity 2 plus 1 squared. First, we solve the parentheses. 2 plus 1 equals 3. Next, we evaluate all exponents. 4 squared equals 16, and 3 squared equals 9. Now we multiply 3 times 9 to get 27, then add 16 plus 27 for our final answer of 43. Remember, parentheses and exponents are your first priorities in any mathematical expression. Always work from the innermost parentheses outward, then evaluate all exponents before moving on to multiplication, division, addition, and subtraction. Now we focus on the middle operations in PEMDAS: multiplication, division, addition, and subtraction. These operations follow a crucial left-to-right rule when they have equal priority. After handling parentheses and exponents, we encounter multiplication and division. These two operations have equal priority in PEMDAS, which means we perform them from left to right as they appear. Similarly, addition and subtraction also have equal priority. When you see these operations together, you work from left to right, not addition first, then subtraction. Let's start with our first example, 10 divided by 2 times 3. This expression contains both division and multiplication, so we work from left to right. First, we perform the division. 10 divided by 2 equals 5. Notice how we highlight the operation we're currently performing. Now our expression becomes 5 times 3. We perform this multiplication to get our final answer of 15. Our second example demonstrates addition and subtraction. 8 minus 3 plus 2. Remember, these operations have equal priority, so we work left to right. First, we perform the subtraction from left to right. 8 minus 3 equals 5. Now our expression becomes 5 plus 2. We perform this addition to get 7 as our final answer. Our final example combines both rules. 12 divided by 3 times 2 plus 5 minus 1. This expression requires us to apply the left to right rule for both multiplication, division, and addition, subtraction. First, we handle multiplication and division from left to right. 12 divided by 3 equals 4. Next, 4 times 2 equals 8. We continue working left to right with our multiplication and division operations. Now we have 8 plus 5 minus 1. We handle addition and subtraction from left to right. 8 plus 5 equals 13. Finally, 13 minus 1 equals 12. This is our final answer, demonstrating how the left to right rule applies to operations of equal priority. Remember the crucial left to right rule. Multiplication and division have equal priority, as do addition and subtraction. Always work from left to right when operations have the same level of priority in PEMDAS.